Okay, good morning, everybody. Welcome to the University of Louisville. We got an exciting announcement today about our Superfund Research Center. To tell you more, I'd like to introduce our interim president, Dr. Lori Stewart-Gonzalez.
Thank you, John. Thank you. Thank you. Good morning. Thank everyone for joining us today as we celebrate our Superfund Research Center. So in 1979, the Environmental Protection Agency began investigating a large toxic waste dump site just outside of Louisville in Bullitt County. It contained thousands of steel drums, and approximately 140 toxic chemicals were polluting the groundwater, soil, and surface water. The discovery of the waste at the site, known as the Valley of the Drums, in part led to the federal government to create the Superfund program in 1980 to clean up that site and hundreds of other toxic waste sites across the United States, and to fund research to understand and reduce the health impacts of exposure to the toxic chemicals that polluted the land and communities around the sites. The University of Louisville was proud to first be named a Superfund Research Center in 2017. And our wonderful researchers began work to understand and mitigate exposure to chemicals found at Lee's Landfill, a Superfund site in southwest Louisville, that exposed residents in the areas to dangerous organic compounds, or VOCs. Under the leadership of Professor Sanjay Srivastava, researchers at the center, now part of the Christina Lee Brown Envirome Institute, where we are today, have undertaken multiple studies to detect and monitor VOCs and document their effects on the heart and immune system. As we all know, heart disease is the leading cause of death worldwide, and heart disease, along with type 2 diabetes, obesity, fatty liver disease, affect a disproportionate number of our citizens in Kentucky, which is why this research is particularly important to all of us here today. And we do know that lifestyle factors contribute to these diseases, but these researchers are also finding that exposure to toxins in the environment can make them worse. So it's essential to understand the role these toxins play in the health of our communities and how to reduce their effects. All of this is why I'm extremely pleased to announce that the University of Louisville Superfund Research Center has been awarded $10.8 million in renewed funding by the National Institute of Environmental Health Sciences to continue and accelerate this essential work. I think that's worth a round of applause. So this 5-year funding renewal represents a 60% increase over the previous funding of the center, which tells us how successful these researchers have been in their work. Congratulations to Dr. Srivastava and to the researchers and staff members who are working to reduce the effects of these toxins on the people of Kentucky and anywhere these toxins are released. So thank you, Doctor. We appreciate it. And now it's my pleasure to introduce Kevin Gardner, U of L's Executive Vice President for Research and Innovation, to tell us more.
Thank you, Lori. I want to start by congratulating Sanjay and the rest of the team. It takes a big team of premier scientists like Sanjay, who you'll hear from momentarily, to go after and be awarded a grant like this. This is really at the sweet spot of what University of Louisville research is about. It's about new discovery, new knowledge generation that impacts people and communities. And people and communities, broadly speaking, that means all people in communities in Louisville and around the country. I want to also recognize, and as I look around the crowd here, I see a lot of faces of the other faculty and staff members that it takes to compete for a project like this, but do the work that got them this project to begin with. It takes people that are out in the community doing hard work. It takes people that are submitting grants to federal agencies and a whole bunch of behind-the-scenes type of work that make this kind of research possible. So there's scientists in the laboratories, there's students, postdocs, staff members in the research office and in the School of Medicine. So it takes a really large team, and I want to make sure that everybody gets recognized that has contributed to this fantastic effort. I want to emphasize the University of Louisville is committed to research and research that makes an impact. So in this case, some of our major research thrusts at the university are human health and the environment. We all know conceptually that humans affect the environment, but we also live in the environment and the environment affects us. And this is exactly what this Superfund Research Center is all about. So to tell you more about that Research Center, I'm going to introduce Dr. Sanjay Srivastava, who's a professor of medicine, a distinguished university scholar, and the director of UofL's Superfund Research Center. Sanjay.
Thank you, Kevin, and thank you to our interim president, and a special thanks to Dr. Ganzel, who has been a big supporter of the program, and distinguished guests. We started working on this project around 2012, when some of our senior researchers got together and started building a program like this. And eventually we got funded in 2017. So you can think about how much time it takes to build a program like this and then sustain it. I think is very gratifying. So the focus of our center is to look at the effect of airborne toxicants on heart disease primarily, and in addition, we also studied liver disease, inflammation, and diabetes. So we know that there are about 9 million people die prematurely because of pollution. And out of those 9 million, 6 million deaths per year are attributed to air pollution. So that's the focus of our work. The reason we are interested in air pollution is beyond that. It's very much of local interest. So in 1940s, starting around that time, there was an industrial revolution sort of thing in West Louisville area where we were producing rubbers for the World War II requirements. And around that time, we started generating a lot of airborne toxicants, which at that time, people did not know what their potential health effects could be. And eventually, later on, we realized that several of those chemicals are injurious to health in various ways. So Louisville has a history of higher levels of exposure to these airborne toxicants. And the class of compounds that we are primarily focusing on are called volatile organic compounds. These are airborne toxicants which are generated by combustion. They are in petroleum products, tobacco products, industrial solvents, and a number of household items. So we are exposed to them in various ways. In the previous round of funding, our center did many things. One of them was to develop new technologies for the measurements of these of these chemicals. We developed some gas sensors, and we developed portable GCMS system, which is really very useful for doing the real-time monitoring in the field. That part was developed in collaboration with Washington University. In the health effects side, we studied the exposure to these chemicals on human health. We enrolled 700 participants to the study, and our major findings were that exposure to some of these airborne toxicants increases blood pressure, damages the blood vessels, and then impairs their potential repair. Our lab experiments showed that exposure to individual chemicals such as benzene can cause insulin resistance and impair the function of the heart and potentiate the accumulation of cholesterol in the arteries, leading to heart disease. So building on those initial findings, now we enhance our program and do a prospective. Now we are going to do a prospective studies where we are going to enroll 1,200 subjects or participants to the study, and we will follow them after 2 years, 4 years, and if potentially we get further funding down the road, then for a longer period of time, and see how exposure to various these airborne toxicants affect the health, especially the heart disease, fatty liver disease, and diabetes. And in addition to the ongoing studies that we are doing from the environmental perspective, we are also interested in looking how remediation to these chemicals could be beneficial for health, primarily because with the climate change, we see that the thermal stress could potentially change the toxicity of these chemicals. When you have wildfire, then you are making all these chemicals in larger quantities. So if we can come up with ways to remediate them in the environment, then that would be very beneficial. For that, we are taking two-pronged approach. One, we are using thermal decomposition techniques, which are primarily doing in the lab. That project is being done in collaboration with the Yale University. And the other part of the remediation process is, many of you might have heard about the Green Heart project here in Louisville, where we are enhancing the tree canopy and trying to see if increasing the vegetation could quench these volatile organic compounds and detoxify them, so we have a cleaner air. So for these prospective studies, we will have 1,200 participants, and then essentially we will look at the various health outcomes. In addition to doing the proposed studies for the center, I think this funding of this center also helped in many ways in building the infrastructure for us to do more comprehensive and difficult experiments. This also came in handy during the unfortunate COVID pandemic, where the team built by us to do the field monitoring community engagement was very helpful in dealing with the initial identifying the population exposed to COVID, doing all the helping out with the measurements of virus and so forth. So for the community level measurements of VOCs, in addition to the technology developed by the center at that time, we have also, because of pandemic, started working on the wastewater and tried to look various sources of these pollutants which could be there in the wastewater. So essentially, we will be monitoring the VOC levels in the air, in the indoor and outdoor air, and we would look at the wastewater to look what are the potential sources of these VOCs, and then for personal exposure, we will look in the biological specimens from the participants of the study. We will also look the proximity to hazardous waste site and see whether people living closer to those sites have increased exposure and potentially adverse health effects. And I take this opportunity to acknowledge various project core leaders on the team, as well as the students, the technologists in the lab who really make it possible. And with that, I'm open to any questions that you may have. Thank you. How is it going to impact? Yes, so we are exposed to these chemicals all the time, but the levels of these chemicals are going to be increased in the conditions that I said, like with the climate change. If you have wildfire, then you are going to generate molecules like acrid and crotonaldehyde, some of these VOCs. These VOCs are also abundant in gasoline products and automobile exhaust and so forth. So we are always exposed to these chemicals, but the levels of exposure is continuously increasing. And that's why we are more susceptible to the adverse health effects.
Maybe talk about remediation, the remediation aspect also, ways to remediate that.
Yes, so for the remediation part, as I said there, we are taking two different strategies. One is that we can use the thermal decomposition of the VOCs, where we can break it down to smaller, non-toxic molecules. And the other part is if we increase the vegetation, then several of these VOCs could be quenched by the trees, or there could be microbial quenching and detoxification of these VOCs. So that is another project that we are looking at, how increasing the vegetation could potentially decrease the levels of these VOCs. That's one part. The other thing is that some studies that our collaborator, Dr. Aruni Bhatnagar, is leading that project, where we are looking at some of the molecules emitted by the trees may have beneficial health effects. And some of our initial results show that it can prevent some inflammatory responses, but those studies are still in the preliminary stages.
Can I add to that?
Sure.
I'm a super simple guy, so I'm like, oh yeah, like simple, I can do simple. So this is the way I think about it. You can tell me if I'm wrong. Like, there are VOCs in the environment. People are exposed to them in their home because they're next to the hazardous waste site, because they're filling up their car with gasoline, whatever. They get exposed, and then they have health effects. What effects are those? How much do they get exposed? We don't really know that, but they're going to figure that out. This is what your exposure is. And then what can you do about it? And that's the remediation part. So maybe you get a lot of exposure in your home, and there's ways that you can treat the VOCs or reduce your exposure. So where's the exposure, what's the impact, and then how do you treat it? That's what I would say as a simple guy. But is that?
Yeah, so the long-term goal is that if we get a VOC sensor that you can either have it at home, or you can have it as a wearable device to really see what level of exposure you are getting and hook that up with potential health effects. All right, thank you.
Thank you, Doctor, and congratulations. Thanks, everybody, for being here today. That concludes our program, and if any members of the media need any one-on-one interviews, we can help you with that. But again, thanks and have a great day.